Good morning, everyone. I welcome you all for today's session. So, in today's session, we'll be starting with module number 4, that is torsion of shafts. Right, so, to begin with today's video lecture, we need to know certain important concepts which many of us are aware of, but still, as a part of this module, I'll just revise them or I'll just refresh them, and I'll also tell in detail for the people who don't know these concepts. So let us begin with today's video lecture. So whenever I say torsion, the thing which immediately comes to our mind is rotation about an axis. Right? So how you rotate a particular object about a certain axis or about a certain point. So this rotation of certain object with respect to certain point or with respect to certain axis can be done by two ways. So which are those two ways? It can be either achieved by using a single force, or it can be achieved by using a couple of forces. Right? So what I want to tell here is, so there are two cases. So in case number one, what I can say is, so there is certain point over here, right, and there is certain force which will be acting at certain distance from this. So let me take this distance as d, right. So this point is called as moment center. Moment center. Why? Because a moment is caused with respect to this point, right. A moment is caused with respect to this point. Now let us say the load which is acting here is p. So what will be the moment in this case? So in this case it will be force into perpendicular distance. Now force is p, perpendicular distance is d. So this force is causing a clockwise moment with respect to this point, which is moment center. Right? So this force is causing a rotation in clockwise direction. So I'll just show the direction here. So it will be trying to rotate the object with respect to this point in clockwise direction, right. So this rotation is caused because of this force which is acting downward at certain distance from the axis or the moment center. So this is case 1. So in this case you are having a rotation in clockwise direction because of a single force. Now I'll go for case number 2. This is slightly different. In this case the rotation is caused because of two forces. So let us say there are two forces. One force is acting downward, so it is P, and another force is acting upward, its magnitude is also P. These two are separated by a certain distance, say Y. Right? Y is the distance between these two forces, and these two forces are rotating the object with respect to a certain point. Right? So let me say this distance is X. Right? So once again this point is same, that it is, what is this point called? It is called as moment center. Right? Now here you concentrate on these two things. Concentrate on these two things. And what will be the moment here? In this case, it will be P into x plus y, right? And one P is acting downward, so that will be P into x. Now the difference what you find here in these two cases, what is the difference you are finding in these two cases? The difference here is, here you are having two equal and opposite forces which is causing a moment with respect to certain point, and in the first case there is only one single force which is causing the moment with respect to a single point, right? So this case, that is case number one, is called as moment of resistance, sorry, moment of force. This is called as moment of force. So case number one is called as moment of force because there is a single force. So what is the magnitude of that? It is force into perpendicular distance, P into D, right? Now same thing in the second case, it is called as moment of couple. Why it is called as moment of couple? Reason is simple, because you are having two equal and opposite forces, right? Two forces, so it is called as couple. There is single force, so it is called as moment of force, right? So if I just separate these two things, just to avoid confusion, these two cases, I'll just draw a line over here. Okay, now what I can say here is, in this particular case, P force which is acting upward into perpendicular distance. So perpendicular distance with respect to this point is x plus y. So I'll be just taking anti-clockwise positive and clockwise negative, right? So in that case, what I'll be getting here, P into x plus y, P into x plus y minus P into x, P into x, force into perpendicular distance, because I'm taking everything with respect to this point, right? Now if I proceed further, what I'll be getting, P into x plus P into y minus P into x. So the resultant will be P into y. So these two things are going to cancel each other, right? Now this is called as moment of couple because you are having two equal and opposite forces, and these two forces are causing a moment with respect to certain point. In the first case, it is called as moment of force because there is only one single force which is causing the rotation or moment with respect to certain point. In both the cases, the point about which it is making the rotation is called as moment center. Right, now I'll give you certain examples for this. So those examples also I'll just note it here itself so that confusion is avoided. Right, just extend this. Fine. So what can be the examples for these cases? So if I want to quote an example for moment of force, in this case example can be opening of bolt using a spanner, right? Opening of a bolt using a spanner. So this can be an example of moment of force. We are having a certain point, let us say you are having certain point, and with respect to this point I am going to apply certain force. in a single direction, right? So this is a spanner. I'll be putting it here and I'm going to rotate like this. So with respect to certain point, I'm applying certain load which is creating the rotation. So opening of a bolt using a spanner comes under moment of force. Okay, the example in this case, that is second case. So let me try to give you some certain example which is encountered in day-to-day life. So one such example is use of steering wheel. Use of vehicle steering wheels, right? So for a four-wheeler, you know, it will be having a steering. It may be truck, it may be van, it may be bus, anything it may be. So in those case, what you observe is the driver will be using both his hands to steer the vehicle. So that will be an example of moment of couple, because what the driver does, he'll be holding it like this and he'll be steering the vehicle, right? So that comes under the case of moment of couple. So another example may be opening of the bottle lid, right? Opening of the bottle lid or bottle cap, or opening of the tap. So that also you can take it here. Opening of water tap. So wherever there is water tap, what I'll do, I'll just rotate it, the top of the tap. So I'll be rotating it like this. So this is one force, this is second force, right? So that is what you do. So that is opening of water tap comes under moment of couple. So why I am telling these things? Because ultimately these things are going to connect to torsion, right? So after knowing these two things in detail, now I'll go for definition of torque. I'll go for definition of torque. So what is torque? So torque is nothing but it is moment about the longitudinal axis of the shaft. It is a moment about the longitudinal axis of the shaft. Right, so that is how you define this. Now the question arises, what kind of moment? Is it moment of force or is it moment of couple? So if you ask me, it can be both. It can be either moment of force or it can be either moment of couple. Now what will be the difference caused? What will be the difference caused? So the difference is nothing. It is a very minute difference. If you are having this kind of case, that is moment of force which is causing the rotation, so this leads to combined bending. This leads to combined loading. But what, why I am saying combined loading? Because this force which is acting at certain distance from the moment center is not only going to cause the rotation, but it will also cause the bending, right? So it is ultimately going to create the bending as well as rotation, whereas in this case, just because you are having two equal and opposite forces, so the bending is eliminated and it will just cause the rotation of the object with respect to the particular axis. I repeat, in the second case, it will lead to pure bending, whereas, pure torsion, whereas in the first case it will be leading to combined loading. It will be leading to rotation as well as bending. Right, so that is the difference between moment of force and moment of couple. No doubt both will be leading to torque, but in the first case it will lead to combined loading, whereas in the second case it is pure torque, right, or pure rotation. So after knowing what is torque, we need to go for what is torsion. What is torsion? What is torsion? Right? So how you define torsion? So it is the twist produced due to externally applied torque. It is defined as the twist produced due to externally applied torque. Right? So I told you what is torque. Now after telling you what is torque, I am going to define torsion. So torsion is defined as a twist produced due to externally applied torque. Right? Now next thing is I'll be telling you regarding shear stress due to torsion. So wherever there is torsion, there will be shear stress. Right? So how this shear stress comes into picture, we'll be just studying a bit regarding that. So next thing for you people will be, so next concept will be shear stress due to torsion. Shear stress due to torsion. So shear stress is denoted by tau. And so in order to make you understand this particular concept, what I'll do, I'll be taking a particular shaft. Shaft may be of any diameter, it may be solid shaft, hollow shaft, that will come to it later. As of now, I'll be taking it as a solid shaft. So it is having certain diameter and certain length. So let us say it is the shaft what I have considered. Right. So if I just try to draw the cross section here, let us say the cross section is circular in nature, then there will be some longitudinal axis to this. What is longitudinal axis? So it is the axis which is coming onto the shaft in x direction. So let us say I'll be marking the longitudinal axis, right? Sorry, after marking this, let me mark the length of the shaft. This is also important. So let us say the length of the shaft is L. Length of the shaft is L, and diameter of the shaft is, okay, let us say this is the diameter of the shaft. So this is the symbol for denoting diameter, right? So diameter of the shaft is D. Now I will assume that this particular shaft, which is having certain length L and which is having a circular cross section of diameter D, I'll assume that this entire length of the shaft is divided into small circular elements, is divided into small circular elements or circular disc. Okay, why I am doing so, you'll get to know in a while. So for time being, let me assume that this entire length of the shaft is made up of n number of circular discs, n number of circular discs. Okay, now I'll be applying certain torque. I will be applying certain torque on this end like this. So let us say I have applied certain torque T with respect to the longitudinal axis. Okay, it is defined as a twist produced due to externally applied torque. So what is torque? It is the moment about the longitudinal axis of the shaft. So this blue color line is the longitudinal axis. About that I have applied certain torque. Now what happens in this case? Each circular disc which is placed here on the entire length of the shaft will try to move relative to each other. Suppose this is one circular disc, this is second circular disc, it will try to move relative to each other, right? It will be trying to move relative to each other. Why? Because you have applied the torque. Now this relative motion, suppose there are two discs, this is disc 1, this is disc 2. As I told you, these are going to try to move relative to each other. So when they are trying to move relative to each other, so there will be some area of contact which will be there in between these two discs, and this area of contact which is coming into picture will be subjected to shear stress. What I am trying to tell here is, you take two discs and you just rotate it, right? So the discs which are here, because of application of this torque, they are going to move relative to each other, and this leads to the generation of shear stress. Now let us say this is one disc, this is second disc, right? And these two discs are like this. So when these two discs will move like this relative to each other, when these two discs will try to move relative to each other in this manner, so there is certain friction created in between this, and on this surface which is the cross-sectional surface, a shear stress is generated. I repeat, I'll just take up two discs, any two discs. So let me say this is my disc number 1, this is my disc number 2. These are coming in contact. Because of application of the torsion, these are moving relative to each other like this, right? So when these are moving relative to each other, the contact surface, that is the cross-sectional surface in this particular case, will be giving rise to shear stress, or you can also call it as transverse shear stress. That is how shear stress comes into picture because of torsion, right? So let me just write this for you people. So I have just noted whatever I have explained to you in the previous slide. So each circular disc will try to move relatively with respect to each other. I told you with the example of a coin how they try to move relative to each other because of externally applied torque, and this leads to generation of torsional shear stress, right? This leads to generation of torsional shear stress, torsional shear stress, and this will be always acting on the cross sectional plane, right? So that is important, this will be always acting on the cross sectional plane. So let me underline this. This is important. Always acting where it is acting on the cross sectional plane. Right? So this is important and you need to remember this. So this particular thing tells you how shear stress is coming into picture because of externally applied torque. So once if this is clear, next a very common question which pops up in a student's mind as well as a teacher's mind who are new over here, that is moment of force and moment of couple, which I have explained in the starting of this session, are both same or is there any difference? So if you ask me, yes, there is a difference. Now what is that difference? I'll be just telling you, right? So first difference or the major difference, so I'll just take the title as difference between moment of force and moment of couple. Right, so what is the difference? Major difference. So the major difference, I'll just try to convince you by taking an example. Once again, I'll be taking two cases. So in the first case, what I'll be doing, I'll just try to quantify things so that things are clear for you people. Now I'll take certain point. Now what is this point called? So this point is called as moment center. Moment center. Right? Then I'll be taking certain force. Let us say I'll be taking certain force in this case. So it is P is 10 Newton, just for example. And this distance here is 2 meters. Right? So what will be the magnitude of moment of resistance, sorry, moment of force? I'll just take 2 to 3 cases so that you get convinced. Then out of these 2 to 3 cases, I'll come to an conclusion. Right? Now in this case, what will be the moment? So magnitude of moment of force. So what will be the magnitude of moment of force? It will be force into perpendicular distance. So it will be 10 into 2. So let us say it is 20 Newton meter. Right? So if you want to take clockwise as negative, because previously you have taken anti-clockwise as positive and clockwise as negative, then I'll be giving some minus sign here. So it is minus 20 Newton meter. So this is case number 1 for magnitude of moment of force. Now what I'll do, I'll make a small change. What is that small change? I'll keep the moment center as it is. Now I'll apply certain force, same force, that is 10 Newton. In this case, this distance is 4 meters. Right, once again same thing. I need not write it again and again. I hope by this time you are able to understand what is this. This is moment center, the point with respect to which I am having the rotation being caused. Right, now how you calculate the magnitude in this case? So magnitude of moment of force. So once again it is force into perpendicular distance. So it is 10 into 4. If I take clockwise as negative, it is right. It is minus 40 kilonewton meter. Right. So it is just Newton meter. You just strike this kilo out because I have taken it as Newton. Now what you observe from these two cases? What you observe is magnitude of moment of force is changing as the distance between the force and the moment center is changing. Right. Now what happens in case of moment of couple? So let us say this is moment center. Now I am having certain force here, having one more force here which is acting upward. So same, I'll take P is equal to 10 Newton. P is equal to 10 Newton. So this is 2 meters and this is 1 meter. Right. Now once again this is moment center. Right. Now how you calculate the magnitude in this case? So in this case, magnitude of moment of couple will be equal to, right? So I just write the sign convention here. I have taken clockwise as negative. In this case I'll be taking anti-clockwise positive, clockwise negative. Right? So magnitude of moment of couple, it is this force P which is acting upwards into perpendicular distance. So perpendicular distance is 2 plus 1. So it is 10 into 2 plus 1. It is causing anti-clockwise. Anti-clockwise is taken as positive, minus because it is clocking, it is moving in a clockwise direction. So it is 10 into perpendicular distance which is 1. So it is 10 into 3 which is 30 minus 10. So it is 20 Newton meter. So that is the magnitude. Now in the second case, I'll make a small change. I'll keep this distance same and I'll change this distance. That is the distance between the moment of the couple, perpendicular distance between this couple and the moment center. I'll be changing this. Now let us see what will be the effect. So now you concentrate. What I have done, if you just compare these two diagrams, the distance between the two couples, it is 2 meters. Here also it is 2 meter. But yes, the distance between the couple and the moment center, here it was 1 meter and here I made it as 2 meter. So now if I just calculate the magnitude of moment of couple, so what I will be getting? Same sign conventions, 10 into 2 plus 2, 2 plus 2. It is anti-clockwise, so it is positive, minus 10 into 2, 10 into 2. So what will be the result? It is 10 into 4, it is 40, minus 20, it is 20 Newton meter. Right? Now you need to concentrate on this. You need to concentrate on these two figures. What you observe, you are observing that your observation will be that the magnitude of moment of couple remains same. The magnitude of moment of couple remains same as long as the distance between the couple of forces remains same. Very important. The magnitude of moment of couple remains same as long as the distance between the couple remains same, right? So the distance from the moment center has changed, but it is not putting any effect on the magnitude, because as long as this distance between the two forces I am going to keep it as constant. You place this moment center anywhere. You can either place it here, you can either place it here, you can either place it here, anywhere from the couple of forces, at any distance from the couple of forces. As long as the distance between the couple of forces remains same, the magnitude of moment of couple will remain constant. But here it is not like that. As the distance between the force and the moment center is going to change, the magnitude of moment of force is going to change, right? So the magnitude of moment of force depends on the distance between the moment center and the force, and here it is going to remain constant even though that distance is going to change, as long as the distance between the two forces is going to remain constant. So that will be your conclusion, right? So I hope things are clear. We'll meet in next session. Have a good day. Take care. Bye bye.